Hello everyone. In this lecture, I will discuss about impulse response of Z transform. The first problem is determine the transfer function and unit impulse response of system using Z transform. The function is yn equal to half y n minus 1 plus 2 into xn. Taking Z transform of yn, after Z transform we get yz equal to half of z inverse 1, this is time shifting property, into yz plus 2 into x of z. Bringing this part to the left side of the equation, we get y of z minus half into z inverse 1 into yz equal to 2 into x of z. After solving this equation, we can find yz by x of z equal to 2 by 1 minus half into z inverse 1, and yz divided by x of z, this is the impulse response, and this is h of z, transfer function h of z. Finally, h of z equal to 2 into z by z minus half. We know that a to the power n into u of n, the z transform is z divided by z minus a, and here, and if we taking inverse z transform, we can find the previous function. If a equal to half, then z transform is z by z minus half. That means taking inverse z transform in both sides, we can find h of n equal to 2 into half to the power n, a equal to half into unit step signals, or h of n equal to 2 into 1 minus n into unit step signal. This is answer. Now second problem is the sequence x of n with z transform x of z equal to z to the power 4 plus z square minus twice z plus 2 minus 3 into z to the power minus 4. That means x of z equal to the function, and the impulse response h of n equal to 2 into delta of n minus 3. Here x of z is applied as an input to linear time invariant system LTI with impulse response h of n. What is the output at n equal to 4? That means if we take the z transform of h of n, h of z equal to 2 into z to the power minus 3, we know that z transform of delta of n is equal to 1, and z to the power minus 3 into 1, z to the power minus 3. Here we will consider time shifting property, and the shifting value is minus 3. That's why the z transform is final z transform is z to the power minus 3. Now h of z equal to y of z divided by x of z, the transfer function, and y of z equal to s of z into x of z. That means if we now we putting the value, the function h of z and x of z, and finally we get y of z equal to this value. If we consider the coefficient of z, then we can find y of n. That means here the coefficient is 2 and here z to the power 0, and this coefficient is 0, and here z to the power minus 1, z to the power minus 2, minus 3, z to the power minus 4, z to the power minus 5, z to the power minus 6, z to the power minus 7. That means, and their coefficient is respectively 2, 0, 2, minus 4, 4, and 0, 0, 0, 0, and finally z to the power minus 6 is minus 6, minus 7 is minus 6. Here what is the output at n equal to 4? That means when n equal to 4, that means this is the first component and this is the first component. Here n equal to 0, here n equal to 1, here n equal to 2, n equal to 3, and here n equal to 4. That means when n equal to 4, yn equal to 0. Here's I ending my lecture. Thank you.